Okay, so let's start our lecture today. So, uh, okay, so, um, yeah, so last time we defined the antiderivative of the y stress p function, and then we showed that this function is actually, okay, we want to show that it satisfies the condition that, okay, so basically, I think last time we are left to show that I think I have a term, let's say, uh, uh, yeah, so we are left with a term summation W, yeah, so omega not to, yeah, omega not equal to 0 of this omega 1 over omega squared. So why this term is actually convergence, right? Yeah, so so why this is convergent? Convergence. So you're dividing by something a complex number squared. So what do you really mean by yeah, what do you mean by dividing by this complex numbers? Let me see. Yeah, so okay, so suppose that okay, so suppose that you have let's say so if you have omega equal to n1 omega 1 plus n2 omega 2, right? And then no. Okay, so here you have that this is all n1. Let's do this. R1 e to the I theta 1 plus n2 R2 e to the I theta 2. So if you square that, okay, so Okay, so let's think about that intuitively. Okay, so um, so we know that this omega basically is the lattice point, right? So besides origins, so basically you have the omega 1, let's say omega 2 here, and then you are having these lattices. Let's see, what is omega 1? Okay, so let's make our life simpler. Okay, so let's say that this omega 1 is just here, or omega 2 is here. Okay, let's suppose that we are in this case. Okay, so then we are interested in like just this lattices. Okay, lattices. And then so okay, so okay, so for one lattice, suppose that this is like r e to the I theta. Okay, so where this radius, okay, so over this line, it kind of has some fixed angle theta, right? Yes, so it has some fixed angle theta. Yeah, because basically you're just extending, doubling the what's it called? The length, right? So this is like a similar triangle here. Okay. So you have a yeah, so it's just like this point, they have the slope on they are on the same line. Okay, so they are on the same line. Okay, so yeah, so therefore what we do is that we okay, so when we take the 1 over r squared e to the I theta squared, so yeah, so then we just forget about omega 1. Okay, we just think about this 1. Okay, so what will happen? So roughly speaking, it is 1 over r squared. Okay, so what happened? Yeah, so what happened to this 1 over e to the I theta? So namely r squared times e to the negative 2 I theta. Okay, so so this angle is theta, right? And then 2 theta. Okay, so you are doing like a reflection, right? So you are doing like a reflection here. Okay. Yeah, so you are doing a reflection. So, and then okay, so does this okay, let's think about this one. Okay, so this one is actually it has the same radius, right? So it is like r e to the I negative theta. Okay, let's just assume that this theta is this theta. Okay, so then this is the r equal to negative r theta. Okay, so then this point we were taking the point A. Okay, so this is like 1 over a squared. Okay, so this is like 1 over a squared. Okay, so and then so you have 1 over b squared, 1 over r squared e to the negative. Wait, hold on. Oh, so e to the negative I theta squared e to the negative 2I theta, which is 1 over r squared e to the 2I theta. Okay. Yeah, so therefore, sorry, there's a square here. Oh, so, okay. Okay, so then let's think about this point. Okay, so what about this point? So this point, it has coordinate r e to the, so now this is like theta plus pi, right? Okay, so this is like point C. Okay, so this is like 1 over b squared. This is point B. Okay, so then you have 1 over r squared e to the 2, oh shoot. Okay, 2I theta plus pi. Okay. So this is equal to 1 over r squared times e to the negative 2I theta plus 2 pi I. Sorry. Minus 2 pi I. Okay. Which is exactly equal to 1 over r squared e to the negative 2I theta. Okay. And similarly, we can also show that, so this one is exactly the same as this one, right? Because it is just like adding an angle of 2 pi, and then if you square it, then it becomes like something plus 2 pi, right? So then you may have like the point D. So this is like equal to 1 over c squared. Oh, okay. And then 1 over d squared. So which is must be same as 1 over b squared. So it's equal to 1 over r squared e to the 2I theta. Okay. So when you add them up, okay. So let's say that you have these 1 over a squared plus 1 over b squared plus 1 over c squared plus 1 over d squared. So this whole thing will give you just the 1 over r squared times. Okay. Some angles. E to the, so 2 e to the 2 I2 theta plus okay, so let's pull out the 2 here. Okay, plus e to the negative 2 I 2 theta. Okay. So can we find an estimate for this guy? So so we know that it lies on the unit circle for the e to the 2I theta, right? So and then e to the negative 2I theta. So so when they're added, I think this number is actually so yeah, so the modulus of e to the I2 theta plus e to the negative I2 theta, so must be less than 2, right? Because by the triangle inequality, right? So yeah, so therefore okay, so I know that the modulus of this guy, okay, is wait. Yeah, I think by showing the modulus is not enough because you have to oh. If you have a sequence whose modulus is convergence, yeah, which means that it converges absolutely, then it is true that the whole sequence actually really converges. Let me think. The modulus of the sequence converges. If the modulus of the sequence converges. Okay. This means that you are summing over or keep adding. I think it must converge because think about the idea that yeah, for the simple idea that after finite many. Okay, so because this is countable, right? So this is at least countable. So wait, why is it countable? Wait, it's there's a yeah, it is countable. Okay, so it is countable. So yeah, and then So basically, yeah. So how do I really show that? So so intuitively, after finally many sums, right? You know that you know that the rest tails. Yeah. So basically, after finally some many terms, the rest tails it would have a very small modulus. The sum will have a more small modulus. So meaning that yeah, how can I really show that? Yeah, so how can I really show that? I think it's a Cauchy sequence. You can show it by it's a Cauchy sequence. Right, and then okay. Okay, so I think the proof goes like that. So here, so what we do is that we use the enumeration. So the enumeration starts from the origin and then it goes like the circling, like 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, yeah, and then after it goes here, then it goes to the next level, and then it goes to here and it goes to the next level, yeah. So okay, so after that we give a let's say an enumeration from 0 to infinity. Oh, actually it's not equal to 0, so it's actually from 1 to infinity. Okay. So okay, so our goal is to show that. Okay, so our goal is to show that summation I from 1 to infinity modulus of omega I. Sorry, 1 over omega 1 over modulus omega I squared convergence. Okay. So we know that. Okay. So if we just look at the first loop, okay. So the first loop actually, so yeah. So even though like if you think of if you think of the modulus. Wait. Okay. Oh, actually, I don't think I even need that. So the modulus of this guy actually, yeah. So if you find the inequality, then actually the modulus is just the r squared, right? Yeah, that makes sense. So okay, so if yeah, it's right. Yeah. Okay. So I think I'm overdoing something. So, okay, so let's see what happened here. So if we take this one, yeah, so this is exactly like 4r squared. And then, okay, so let's think about this one. Okay, so because for the first loop, right, there are exactly 8 points. Okay, so first loop. So there are 8 points, and the total length, total sum. Okay, you can use this band to bound the total sum. So it's less than 8 over r squared, right? And the second loop, because the radius kind of enlarged, right? So the second loop basically it has how many points? How many points does it have? So let me try to think. So so the first loop, is there any way that I can generalize this one? So for the first loop, okay. So the first loop, the side has length 2, right? So it has side has length 2. So therefore, the total amount of loop is 4 times 2 minus 4. Okay. Yeah. So 4 times 2. Sorry. 4 times 3 minus 4. Yeah, 4 times 3 minus 4. Okay. So where 3 is the what? The loop 1 has length 2. Okay. So loop 1 has length 2. Okay. So so loop 1 has length 2, and therefore on each side, and therefore that gives you 3 points. Okay, so basically it's the number of length plus 1, right? Gives you 3 points on each side. On each side. Okay. So totally it's like 3 times 4 minus 4, right? Okay. Okay, so then you have the loop 2 has length what? So loop 2, okay, so loop 2, basically it has length double, right? Okay, so has length 4, which gives you 5 points, okay? 5 points. And then on each side, and then totally gives you 5 times 4 minus 4. Okay. Now, let's say that for loop n, it has length let's see, length what? Loop n, so the length is n here, right? Loop 1 is length is 1. Yeah. Loop 2, the length is like 2. Okay. Loop n, it has length n. So the length is like double, right? Has length 2n. And then gives you which points? 2n plus 1 point, right? And then, yeah, so 2n plus 1 points. And then, on each side, and then, so totally is 4 times 2n plus 1 minus 4. Which is 8n. Okay, that makes sense because the first loop has length 8 and second loop we calculated it has length 16, right? Okay. All right, so, okay, so I think in this case we can actually calculate the actual sum. So, because, yeah, so this sum, we can show that it's just equal to exactly sum over like the loops, right? So for the first loop, the radius is r, right? So second loop, the radius is 2r, and for the nth loop, the radius is nr. So basically what we do is that we sum it over n from 1 to infinity, 8n over nr squared. Okay. So okay, it seems that it diverges because by the harmonic series, let me make sure. So second loop is 2r, third loop 3 times r. Yeah. So it diverges. Yeah, so that's very unfortunate. So wait, okay. So let me double check the question. So okay, so previously I think what we do is that so what did we have previously? So okay, so previously we defined this theta z to be this guy, right? So okay, so previously, so we defined theta z to be, which is the antiderivative of the Weierstrass polynomial, 1 over z plus summation omega not equal to 0 of 1 over z minus omega plus 1 over omega, and then plus z over omega squared. Okay. So here, okay, so here, yeah, so why is it constant? So is there any cancellation happens inside this if we, so yeah, so because maybe there might be some situation because the alternating series converges, right? But it does not converge absolutely. So in this case, I'm thinking about a situation where it could behave something like alternating series. Oh, yeah, I did that. So yeah, so can it happen for the alternating series criterion here? So so here basically we are doubling this angle here. Oh. Wait. Okay, so okay. So in this case, I think because this is yeah, so I think it depends on the theta really. Like if the theta is like really small, right? So for example, you have the letters like that. Theta is like really, really small. And then if you're doubling the angle theta while keeping the radius the same, when you're doing that, then the sum is like almost the same, right? It's almost the same. We are adding them. There is not much a cancellation going on here. So let me think. So and then you have the things that down below. So when you're adding, so really it's like this part being added. Okay, let me write it down again. So if you have 1 over a squared plus 1 over b squared plus 1 over b squared, then it is equal to exactly 1 over r squared times e to the 2I theta plus e to the negative 2I theta. Okay. Yeah, so you are dividing. Okay. Okay. So what should I do? Okay. Or did I make some mistake in my calculation here? but that can, if you have I theta here and I theta plus pi, and then you multiply by 2, then you square it. Square becomes okay. Yeah, I don't think it's okay. So right, so for this guy, let me try to think. So you have e to the I theta here. Yeah, the question is there any cancellation here? I think in this case, if the theta is like 45 degree, then the two thetas is exactly 1, and then the negative 2 theta, which is negative 1. Sorry, I, and then it's negative I, so they cancel out. So does this depend on, let me try to think. Omega 1, omega 2. Omega 1 is already right. Here. These two are in a circle. So in the local coordinate, in the actual coordinate, it is like wait, they're complex numbers. Wait. Oh. Wait. Okay. I think the idea might be that there are because so let's ignore this case for a while. So I think the idea may be that if you look at these points, okay, right. So I think maybe okay. So next time we shall look at this aspect because yeah. So in this case, the theta is like there's only one theta here, okay. So because like here, so if we try to look at the 1-2 style block, okay. So this is like a 1-1 style, okay. So this ABCD they are 1-1 style, okay. Block, okay. So if we look at the 1-2 style, okay. Yeah, so either 1-2 or 2-1, okay. So basically they have the same radius, right? But the angle is like slightly different here, okay. So if we consider, let's say, more and more block like that, there might be some cancellation based on, yeah. So yeah, so if we have that, wait, so each time I think there is only 4, it should be 1, it should be 2-1. Okay, so in this case 1-1 is like symmetric, okay, so this is like symmetric. So in this case, if we have any like mn or something, then it's like mn nm and something like negative mn negative nm, and then yeah. So yeah. So let's see. Okay. So that yeah. So next time we will try to analyze this one. Okay. Yeah, so what is the angle? So this angle is like theta, okay. And then, okay, so this one is what? This one is exactly, so this is 90 degree minus theta, right? So this is like actually power 2 minus theta. Okay, so this angle here. And then we also have this angle, okay. Okay, I think that's very interesting. So this angle is what? This angle is power 2 plus theta, right? Okay, so okay, let's think about that. So this is like R, and then R, and then you have 8 points. Oh, okay. So then this is like what? This is like pi minus theta, right? And then this is what? This is pi plus theta, okay. And then you have another one. So this is 3 power 2 minus theta. And then you have 3 power 2 plus theta. Oh, okay. So okay, so then you have what? You have okay, so I also use the ABCD here. So okay, so let's say that let's call this A